We're going to move on to problem number 7. Which of the following Fisher projections correspond to the structure shown below? Two ways to do this problem. The first way is just to assign chirality to our starting molecule and to the others, or we can just convert our original molecule into a Fisher projection. Converting to Fisher projections can be really hard if you don't have a model kit, which honestly you shouldn't really be constructing these in the middle of an exam. They'll take up way too much of your time. So the first way is going to be your safest bet. Second way is faster only if you've mastered it already. So I'll show that just if you really want to do that. It'll save you time in the long run. But if you don't have that kind of time, need to study, then stick to the first way. Okay, so the first way, we'll just assign priorities on each of these chiral centers. We have 3 that are attached to 4 different things, and we prioritize based on atomic number or molecular weight. So nitrogen in this is farther to the right of carbon on the periodic table, which you should be given on your exam, so you don't have to memorize these, but it'll save you time again. And then you'll move on to the other branches, which are carbons, but this carbon's connected to an O, while the other is just connected to 3 H's. So this will be your second, and this will be your third. Now, the key is, of course, knowing whether the hydrogen that's missing here is wedged or dashed. It's going to be a wedge here just because the other group is dashed. It's always the opposite of the one you're given. And when you have a wedged 4th priority group, you flip your chirality. So we have 1, 2, and 3. We're going to the right direction, which means we flip that into the S. Okay, let's clean up. And on to the next one. This carbon has O hooked onto it, which will easily be 1. Then we'll look at the neighboring carbons. You have to make a decision whether the sulfur is better than the nitrogen. Looking at your periodic table, sulfur will weigh more than it, and it's further down, higher number. So this branch will actually be higher priority than the other. Now your hydrogen's going to be dashed because you have a wedge opposite of it. So that means you keep the same chirality when it's dashed. Here we're going in the S direction. So we can keep that because our lowest priority is dashed. Now we have to look at our last chiral center, and we have sulfur beating these 2 carbons, and this carbon's attached to an oxygen, which will beat out the other carbon. And now we can draw out our wedge because this is dashed, which means flip chirality, and we'll draw out our arrow. It's going S direction, but we have a wedged low priority, so we switch to R. And we end up with the configuration S, S, R. Let's get rid of that. Okay. Now, we only really have to do this on one of these, as I said earlier, because we can assume the rest from just one. Fisher projections, you have to just look at the arms on the horizontal, and if you find that low priority H, we know that it will always be our lowest priority, and if it's on the horizontal instead of the vertical axis, we're going to flip our configuration. And luckily on this problem, that's true for every case. So if our hydrogen was up and down, on the up and down branches up here and down there, we would keep the same, but since they're on the arms right there, we have to flip. Okay, so let's number again. We said nitrogen is the number 1 branch, then the carbon next to the oxygen, and this lastly the carbon with these low weighting nitrogens. Let's draw that out, and we're going the S directions, but again, since our nitrogen is on the arm on the right side or the left side, we have to flip, so it's actually an R. Okay, let's move on to the next carbon. We're at 1 priority for that oxygen because it weighs more than these carbons. This carbon is hooked onto something that weighs more than the nitrogen. So we'll say that this is 2 and this is 3. Let's draw that out. We're going right, but because again the low priority hydrogen is on the left or right side, we can say that it's S. Okay, let's go to the last chiral center. Sulfur is going to be our highest priority, beating out these 2 carbons. This carbon's hooked to H's while this one's hooked to an O. So that'll be 2 and this will be 3. Draw that out. It is going the right direction, but the hydrogen makes it go left instead. Okay. Now from there, we can look at all of these just by looking at what they're connected to, those branches. So we know that the first chiral group will be in R configuration when the hydrogen's on the right and the nitrogen's on the left. So if you look at this, that matches that. It matches this as well. So those are all R, but we want S, so that means we can cross all these out. Okay, now we'll move on to the next one. We have this group over here, and the alcohol or the OH is on the right, and that gives us S. So and that's what we want. In this case, we want an S, so we want either this or this. So every other one's wrong. We already crossed out those, but B also doesn't fit. Okay, last arm. We have sulfur on the left gives us S, but we want R, so all the ones with the sulfur on the left-hand side will be wrong. We only have 2 options left. E has the sulfur on the left, so we know it's wrong. That only leaves us with D. D to be our right answer. Alright, that's the safe way of doing this, and that'll get you it done pretty fast.